Hi, in this lesson, we will do what are the absolute uncertainties and what are the percentage uncertainties, and after that, we will do some past papers questions related to this topic. Okay, so the absolute uncertainties will tell you how the measurements value can vary, right? So let's say if you are having a value 2.5 plus minus 0.2, so that means this 0.2 is the absolute uncertainty, or we can this is the error, so we can say that this is the absolute uncertainty, right? So from this absolute uncertainty we can find the percentage uncertainty as well. So for the formula for the percentage uncertainty, it will be equals to the absolute uncertainty divided by measurement into 100, right? So the absolute uncertainty is the error, possible error in the measurements, that is the 0.2. So and the measurement value is 12.5, right? 12.5 into 100. So by calculating it you can find the percentage uncertainties. Okay, so now the next one is when we are adding the two, when we are adding or subtracting the quantities, their absolute uncertainties are added, right? How can we do it? Let's say the example is, let's say there is a force F1 that is equals to 10 plus minus 0.1, right? And there is another force that is F2 and it is 3 plus minus 0.2, right? So okay, so if you are have to find the resultant, let's say they are asking you to subtract f1 minus f2, right? So if we are subtracting these forces, so that means we are subtracting their values, right? So their values is the value of the f1 is 10 and the value of the f2 is 3, so the value is 7, right? But you we have to if we go to the absolute uncertainties, there is the absolute uncertainty for f1 is 0.1 and the absolute uncertainty for the f2 is 0.2. As we have said that when we are adding or subtracting quantities, their absolute uncertainties will be added, right? So as we are subtracting these quantities, so when we move to the absolute uncertainties, we will subtract them, right? So sorry, we will add them. So their absolute is 0.1 plus 0.2, so that is 0.3. So we will add these ones, so we will get 0.3, so that means absolute will be plus minus 0.3, right? So but if we are multiplying two quantities, right, or we are dividing two quantities on other many, so we will add their percentage, we will add their individual percentage uncertainties, right? So this is we are adding their percentage one. Okay, okay, now let's do their example. Let's say for the density is equals to mass over volume, right? So that means there is a division sign, right? So let's say the mass is equals to 5 plus minus 0.2, right? And let's say the volume is let's say 3 meter cube plus minus 0.02, right? Or let's say 0.1. Okay, so we have to find density. Let's say they ask you to find density and its absolute uncertainty. Okay, how we will do it, right? So first we will find the value of the density. So value of the density is mass over volume, so that will be 5 over 3. So 5 over 3 is 1.66, right? So this is the value of the density, but we have to find its absolute uncertainty as well, right? So absolute uncertainty, as they are dividing, so that means we need to know what is the percentage of these ones, right? So the percentage, so if we find the percentage of mass, so that will be 0.2 absolute divided by measurements into 100. So absolute of sorry, percentage of, so percentage of mass is 0.2 divided by 5 into 100. So that will be 4. So that is a 4%, right? And if we do find the percentage uncertainty of volume, that will be its absolute 0.1 divided by measurements into 100. So it will be 0.1 divided by 3 into 100. So that is 3.33%, right? So now now we are finding percentage uncertainty of density. That will be, we will add these ones, right? So we will add percentage of mass plus percentage of volume. So that is 4% plus 3.3%, that will be 7%. So that is the percentage uncertainty of density. But we need to know absolute uncertainty. So how can we find it? By the using the formula that was, percentage uncertainty is equals to absolute uncertainty divided by measurements into 100. So the percentage uncertainty of density is 7%, and absolute is, and the absolute is, we have to find the absolute one, and the measurement of the density we found 1.66, right? So this is the 1.6, is we calculated it, 1.66 into 100. So when we will calculate it, so we will get the absolute uncertainty, right? So now let's do some past papers questions. Okay, so here is the first question. So what are they asking? They are saying that, okay, so they are saying that the diameter of a ball is measured 5.26 plus minus 0.02 centimeter. That means this is the measurement of the diameter, and this one is the absolute uncertainty, right? Okay, what is the absolute uncertainty in the volume of the ball? Okay, so we know that the ball is a spherical shape, right? So the volume of the ball will be, what is the formula for the volume of the sphere is 4 by 3 pi r cube, right? So radius is not given, but the diameter is given, right? So we can write it as 4 by 3 pi r cube can be written as d by 2 cube, right? So when we substitute the value, first we are finding the value of the volume. So value of the volume is 4 by 3 pi into diameter is given 5.26 over 2 divided whole cube. So okay, when we will calculate it, we will get the answer. When we are doing the calculations, we will get 76.16. Okay, so this is the value of the volume, right? So, or the measurement of the volume, right? Now we have to find the absolute uncertainty for the volume. Okay, how can we find it? As for this formula, we know that this we found that volume is equals to 4 by 3 pi d cube over 2 cube, right? Okay, so when we are finding the absolute uncertainties or percentage ones, what we have to know, we will ignore these constants values, right? We will just say that the percentage of volume will be percentage of diameter cube. So that is the 3 times, because okay, this is there is a power on the cube diameter, so you will take it outside, so 3 times percentage of d, right? Okay, so first you have to find the percentage of d. How will you find it? So the percentage of d is, let's find it here. So the percentage of d is absolute of measurement, absolute uncertainty of the diameter, that is 0.02 divided by its value 5.26 into 100 times 3. So that will be, when you will calculate it, you will get 0.38%. So that is the percentage of volume, sorry, times 3, so this will be 1.14%. So the uh, percentage uncertainty of volume is 1.14%, but we have to find absolute uncertainty in the volume. So that means we just now found absolute one, sorry, we now found the percentage. From this we have to find absolute. So the absolute will be, what is the formula for the absolute is, as the percentage is absolute over measurement into 100. So the absolute of volume, percentage of volume is given 1.14 is equals to absolute uncertainty, and measurement of the volume is 76.16 into 100. When you will move these to the other side, so this will be 76.16 into 1.14 over 100 is equals to absolute uncertainty. And when you will calculate it, you will get 0.867. That is option B, right? So this is how you will do this question. Okay, now let's move to the next question. Okay, so in the next question, a student calculated the density of a solid steel cube, and the measured mass is this one with its absolute uncertainty, and the measured length of the side is 50 millimeters plus minus 1 millimeter with its uncertainty, and you have to find its density. Okay, how we will do it? Okay, so first there first you have to find what is density. Okay, you can see that okay, the most important thing is the unit c. See there, the unit is gram per centimeter cube. So that means you will convert this length from millimeter to centimeter. So when you are converting it, so this will be 50 millimeter, can be 50 into centimeter is 10 power minus 1 plus minus 1 into 10 power minus 1 centimeter, right? So this will be 5 centimeter plus minus 0.1 centimeter. So this is now the length, right, in centimeter. Okay, now you have to find density, right? So the density, the value of the density is, okay, so the value of density is, 1 second. Okay, so first we have to find density. So the density will be value of the density is 975 mass or volume. So mass 975 times over length cube. So this will be 975 over 125. That when will you calculate it? That will be 7.8 gram per centimeter cube. Right. So this is the density. Now we will find the absolute percentage uncertainty of density. Right. For this one, we should know what is the percentage uncertainty of mass plus percentage uncertainty of volume. Right. So percentage uncertainty of mass will be the mass is 10 gram. So it will be 10 divided by its measurement is 975 into 100 plus percentage of volume. Volume is L cube. That means three times of percentage uncertainty of a length. Right. Okay. So when we calculate it, uh, this is percentage of uncertainty of length is 0.1 over its measurement into 100. So when we calculate it, so this will be 1.025, and when we'll do it, so this will be 1.025 plus 3 times of, and when we calculate it, this will be 2. So that is 1.025 plus 6, and that is equals to 7.025 or 7, around 7. So the percentage uncertainty of density is 7%. So that means this will be option B.